This video is a Rodin Coil tutorial on how to wrap the 12-pointed Rodin Coil. And this is an example. This has 12 points, and I'll show you the winding pattern. These have 2 wires. This is 30 gauge wire, and wires are going in the same direction. This one has 24 gauge wire, but you wrap one of them clockwise and then the second one in the opposite direction. This is an interference coil. These are the materials that you'll need. It's actually more than you'll need. And wrap them with these Fisher-Price baby donuts. But these ones are too small, because after you wrap the coil, the hole is significantly smaller. So you have to save room for the wire when you're wrapping it through. So I use the green and the blue coils. This is a spool of 24 gauge magnet wire that I got from BAE Wire. Here is an example of the spool. Now you can choose to get it from magnetsforless.com, and here's the price on that. And you can go to BAE Wire, and the price is $20 less. So I chose BAE Wire. I don't think that Radio Shack or those other places sell it by the spool in the amount that you'll need. You need 72 feet of wire per wire. And you need to transfer that from a spool onto something else so that you can weave it through the coil. I used 2 wooden dowels. These are 6 inches long and a 1/2 inch in diameter. Now when I used 24 gauge magnet wire, which means it has an enamel coating on it, I was able to wrap this wooden dowel about 650 times. So wrapping it around this wooden dowel 650 times is about 72 feet of wire. And that will get you this. And it's since this one is slightly bigger, it'll take a little more wire, but that's why I said 72 feet, because it actually takes maybe like 68 or something for this one, 72 for that one. So just to make it safe, you leave yourself extra wire. And it's really simple. Did this on a protractor just so you can see the winding pattern. Pretty much 12 points, 1 point each of a clock, and it goes every 150 degrees 12 times. And you're going to go 12 points before you end off where you started again. This is a flat protractor, so it's not really going to give the swirl like this one. This is just to give an idea of the winding pattern. So 12 points means that you have 12 turns. And I wrapped this one 14 times, which means I ended up where I started 14 different times. 72 feet of wire. What you're going to need is a protractor. I actually put two protractors together so I can make 360 degrees. And you want to mark out 36 points. So 3 different clocks, evenly spaced. Every 10 degrees, you mark a point. Either do that with a Sharpie, or you can just take a needle and put it right in every 10 degrees, right in the side. You can either use it this way with a protractor on top, or you can mark out on the paper, and then you can put the paper around the side, so that way you have a more accurate around the sides, and then you can just push the pins, 36 of them, evenly spaced. You want 12 red pins, 12 blue pins, and 12 yellow pins. And have some extras just in case the head of the pin falls off. And the rubber bands are to put around the edge of the dowels just so the wire doesn't slip off the edge. Or you can use the electrician's tape instead of the rubber bands. So pretty simple. Take a compass, make a circle, mark the points on the paper, do that, or you can just eye it. That's what I do. It's pretty simple. One here, one here, one here, and here. Do 12 points, and then you shift it over one. So you have 36 evenly spaced points. So let's do that right now. So I'm not even going to use the protractor or anything. I'm just going to eye the pins in 12 points. And the wires you can adjust also once you wrap it. You can shift these around, so if you're off just by a centimeter, you can shift it around. It's no big deal. Twelve, 3, 6, 9. And after we do this with the red ones, it's going to do the same with the blue and then the yellow. So you're just going to have red, blue, yellow, red, blue, yellow, red, blue, yellow. Easy. Let's do it with the blue. Always readjust the pins. Let's do it with the yellow now. Now you're going to make room for 3 wires, but you're only going to wrap 2 wires. I have this one in the freezer, which is why it's all wet. So that wire gets hot with the amp that I use. This one not so much, because it's bigger gauge wire. Alright, well, this is the next step, is transferring the wire from this onto these wooden dowels. And you want to wrap it neatly like a Tesla coil. That's how I know there's 650 wraps on here. If I did it all sloppily, might have more wraps or less. So it's just a matter of taking the time to wrap this around the wooden dowels, just so the wire doesn't come off the ends. And I usually just take the wire here. See if I can zoom in. Usually just take the wire and put it underneath the rubber band like that, just so it won't get away from me. And then it's just a matter of wrapping it pretty much just neatly like that all the way down. .650 turns, and I use this little point sticking out there as a marker, so every time it goes around 1 turn, 2 turn, 3 turn. Usually learn how to put this on something, have a stick on here so it turns easily while you're wrapping the dowel. So it takes just as much preparation for these almost as it does to wrap this. Some people have a jig where they have something they can hand crank and it does it really quickly. I just do it by hand, just take the time to wrap it out and count the turns. So, do 1 wire at a time. So, just getting the wire here. Alright. So you want to make sure you have a good amount of wire to start with. And start at the red at the top, 12 o'clock. Just wrap that around a couple times just to make sure it stays. And now you have the start of the coil. and you follow that winding pattern. Every 150 degrees, which means every fifth red pin. One, two, three, four, five. So go through. One, two, three, four. On the fifth. Turn. Do the same thing. 1, 2, 3, 4 on the fifth. Turn. 1, 2, 3, 4 on the fifth. One, two, three, four on the fifth. And you pretty much do that 160 times or something like that. Over and over and over until you're done with the dowel. You want to pull it too tightly because you don't want to break the wire. But with the 24 gauge wire, you can pull it pretty well. And once you get a good rhythm, it's just a repetitive action. And just keep doing that over and over until, well, now we got back to where we started one time. So we have 12 points. And just do it again. Wrap it right next to it and just follow the path of the last wire. Just try to do it as neatly as possible, and that's pretty much just how you wrap a Rodin coil. It's like crocheting or underwater basket weaving or something. Go ahead. Now you might go too fast or screw up or something. You have to weave your way back in order to get the right thing, or you can just take the pin out and shift the wire over if you mess up. It's pretty simple. It's just a repetitive action over and over and over. And there are no machines that will wrap this because you have to go over and under and then twist the donut. So there are machines that can wrap wires going through here, through here, through here, through here, you know, like this, and then this turns. But Rodin coils have to be handmade for now until a machine is developed to do that. So that is pretty much an example of how you do a Rodin coil. I'll come back after a while when I finish this dowel and see what it looks like. And here is wrap 3. I've ended up where I started 3 times now. We're going to end up doing this 14 times. See? Rubber band. Gotta fix that. I put a new rubber band around that. So we got extras. Alright, now we're at number 4. And so on. So I'm going to wrap the rest of this one. I think you've got the idea on how this works. So I'm going to finish wrapping this one, and then we can choose to wrap the second wire the same way or in the opposite way. On the 10th wrap, now we're on the 14th and final wrap. Alright, got all 14 on there now. See how much wire we got left. So it's going to take about that amount. And we're just going to wrap that around the red pin just to keep the wire there. And so it won't impede our other wrap. Now we can start on the second one. And we can choose to go in the opposite direction, or we can choose to go in the same direction. It's your choice. So I'm going to go in the same direction because we already have one wrapped like an interference coil. And on my last wrap, one of the yellow pins came off, so I just replaced that with one of the extra ones that I had. I'm just going to go right next to this one. Now we're just going to repeat the same action again. But go every 5th blue pin. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. And again, we just keep repeating that, just like we did with the red pins. And if you need more room between here, you can just shift the red pin over or take it out completely now that we've wrapped that section. And that's one complete wrap. Number 3. Wrap 4. Wrap 5. Now starting on wrap 6. Number 7. And number 9. Starting wrap number 10. $11, $12, $13, and we are now on the final and 14th wrap. And we are done with the 14 wraps. Round that around there a few times. About the same amount of wire as before. And now we have a completed Rodin coil, 12 points. And you can take out the pins and shift them around so that they are more evenly spaced. It takes a few minutes. Now if you put a magnet in the center of this, let's get a magnet. And you plug this in like to an iPod, or you have a little circuit or an amplifier or something. This is now a speaker. Take the magnet away, you won't hear anything. Put the magnet in, now it's a speaker. And I have videos below. See the links in the description below. Click Show More, and you'll see a bunch of Rodin coil experiments from myself and from other users. And if you really want to go big, you can see my video of the 120 point Rodin coil, which is a little bit bigger and a whole lot more complex. With this one, we wound this one wire at a time. With this one, I did both wires at the same time, and then did this wire, then this wire, then one turn of here, one turn of here. So I wove it like a wicker basket. It's a 2-foot coil. I call it a lifesaver coil because it's made out of a lifesaver ring. So you can have this coil inside of this one, power both at the same time. You can have this one in this orientation, and then another coil around that one in this way. So there's a bunch of different experiments that we can try. I still have yet to grow crystals in the center of the coil. Let's see. So I have something like a space age crystal set, and something like this little crystal garden. But in order for me to test this, I need a circuit of some kind so that I can leave the power going for like 3 days straight on low power. Otherwise, with the amplifier I'm using now, the wires get too hot or the battery drains in a couple hours. So I have this frequency generator, which I can put a harmonic frequency, but I need some sort of circuit so that I can put that power through the coil for like 3 days while the crystals are growing, and see if the harmonic frequencies affect the growth rate of the crystals or the structure and the formation. I had mentioned this in another video, and I show that you can put this coil underwater with the magnet in the center, and the water will amplify the sound, and you can have this as a speaker underwater. So what if you recorded the sounds of dolphins, and then you played those sounds through the coil underwater? Would it get rid of sharks in the area? Or could you record the certain sounds of a fish during a feeding frenzy and put the coil underwater, play those sounds? Would it attract those type of fish to the coil, thinking that there's food in the area? And there's lots of other things you can do. You can spin magnets in the center of this, hundreds of thousands of RPM. Russ Grease of rwgresearch.com got one spinning up 500,000 RPM. I know he filmed at least 300,000. And if you have ball magnets, you have it set at the right pulses, you can have the ball magnets levitate in the center of the coil. And there's different experiments that you can do with the coils and make magnets bounce around. Marco Rodin, the inventor of this coil, says that if you build it big enough, it would drastically reduce the amount of electricity needed to power a home. But the size coil needed for that would cost like a couple $100,000, and the manpower to wrap that. So lots of different things we can do if these types of things were funded. There is a company called Jovil, Jovil, and they have a machine called the SMC4, and that is a toroidal winding unit. So what that is you have like an iron core or some sort of core, and the wire just wraps around as this turns. So you pretty much have an even wrap like a Tesla coil, but around the rim of the donut. There is no machine as of now that can wrap and weave like this handmade Rodin coil right now. And from what I understand, it would cost about $85,000 to modulate that SMC4 to be able to have more axis to work with, so that these types of coils could be manufactured industrially and quickly. So if you want a Rodin coil, there's no other way to get them other than to make it yourself at this point. So I hope this video showed a bit about how to do that, at least with the 12 point. If you wanted an 18 point coil, I think that's a little different winding. If you wanted a 36 point or 120 point, there are different winding patterns for that. I only know 12, 18, and 120. So, enjoy. Lots of information in the video description again. Thank you.